and we had filled in this much of our little map, saying that to go from vertex form to standard form, we expand. To go from standard form to intercept form, we factor. To go from intercept form to standard form, we FOIL. What we want to talk about today is how we go from standard form to vertex form. And the process that we're going to use there is something called completing the square. I will almost always abbreviate that with the initials CTS, like an acronym, because those are a lot of words to write, and you know, let's be efficient with our writing, you know. Everybody's okay so far? So what we're going to do is we're going to kind of describe the process and do an example kind of at the same time. I'll talk about kind of a little bit about what this process is doing and what we're taking advantage of in order to do it, so that you understand a little bit about why the process is shaped the way it is. And then we'll do some more complicated examples. We'll start with an example that's rather, straightforward. Okay? So let's say we want to take this standard form equation, put it into vertex form. And let's say we have y equals x squared plus 8x plus 7. That's our standard form equation. So the first thing that we'd want to do is we want to make the leading coefficient, or the A. When I say A, I'm talking about the A coefficient in our standard form polynomial, equal to 1. What is the A coefficient currently? 1. So do we have anything to do here? No. There's nothing in front of the x squared. There's nothing to do for that first step. So the next thing I want to do is move that c term to the other side of my equation. So to do that, we'll just subtract 7 from both sides. Everyone okay with that? Again, nothing super tricky happening so far. The next thing we're going to do is we're going to add b over 2 squared to both sides. So again, when I am talking about these a, b's, and c's, we're talking about the coefficients in my standard form polynomial. So for this one, what is my value for b, where I'm currently at? It's 8, right? That's the b. So I'm going to add 8 over 2 squared to both sides. And now I realize that 8 divided by 2 is just 4, and 4 squared is just 16. But I'm going to leave it in this the way I've written it here for a few minutes, because it's going to be a little bit more useful in the next step to keep it as b over 2 squared rather than the way I've currently written it, or rather than writing it as the 16. Okay? So I acknowledge that, but you're going to want to hold off on doing that. What we're going to do then is we're going to factor that right-hand side. And here's the neat part. This factors automatically every time. It's going to factor whatever this part is squared, and then whatever this part is squared. And then I can just recopy things from the other side. And at this point now I am going to write 8 over 2 squared is 16. Why does this factoring work? Well, if you remember from last time, we talked about this special factoring pattern when we talked about expanding. And it's this special factoring pattern that I used to be able to do this factoring. So just as an aside, and right now you don't really need to write any of this specific explanation that I'm about to give you, because I'm going to highlight a bunch of stuff and move back and forth. I just want you to kind of understand what it is that this process or what we've done so far and why we've done it, and why it allowed us to factor that so quickly. The how to factor it is quite easy, but making sure you understand the why helps prevent mistakes from being made in the process, okay? So, my goal when I write something in Vertex form is to make it look like this. The tricky part is getting this piece of it the way I'm going to do that is I'm going to take advantage of this little factoring pattern here. So what I did was I started by dividing both, or making the leading coefficient 1. What that does is it makes my first term basically my u squared. Okay with that? I'm then going to assume that my second term is this 2uv, and I'm going to use that assumption to figure out what this v squared term needs to be. So my 2uv is this 8x. If I want to get v out of that, I have to divide 8x by 2u. Everybody agree with that? And in this case, our u is just x. So when I divide 8x by 2x, I get that the value that I need to complete this perfect square. So once I've got things in this form, where I have u squared, 2uv, and v squared, I can go immediately to this factored form. So that's why we call it completing the square, because we just make the first two terms of our polynomial look like one of these perfect squares, this binomial expansion that we talked about earlier. And then we add something to both sides that makes the rest of it that form, u squared plus 2uv plus v squared, so that we can factor it in this very special way. Is that okay with an explanation? The important part is the how, and the how for the factoring is quite easy, right? You just end up with that parenthesis with the squared, and the first thing is the first thing, and the last thing is the last thing, right? Minus the squareds. Okay. That's that little aside. Done with that. And my last step then is to just now go ahead and get that y by itself. So negative 7 plus 16 is 9. And if I subtract 9 from both sides, I have that. Caden? Sure. Okay, let's do another example of this, where things get maybe get a little bit more complicated in places. So one way that this problem, or these kinds of problems, can get more complicated for students is that a lot of fractions can kind of creep in maybe unexpectedly. Bless you. So let's say we'll do this again, this time with y equals 2x squared plus 6x plus 10. The first step in the process says that we should try to make the leading coefficient 1. What do I need to do to make that leading coefficient 1? Divide both sides by 2. Everybody agree with that? And I know that division, much like multiplication, is distributive. So I know that dividing the right-hand side by 2 is the same as dividing each of the individual terms by 2. Oops. I usually have been writing these in this color, right? Try to be consistent. Probably helps when you go back and look at these. When things are color-coded, you can tell what's the original part and what's the things that we're doing algebraically. So we've gotten that leading coefficient to be 1. What we need now to do is to move that that constant term onto the other side of the equation. So to move that 5 over to the left-hand side, what should I do? Yeah, I subtract 5. Okay, so there's that. And now what I'm going to do is I'm going to add b over 2 squared to both sides. The b in this case is 3. And you'll notice that even though like 3 over 2 squared I can simplify, I'm choosing not to do that yet because in the next step, where I factor this, it's easier for me to factor this if I don't simplify that 3 over 2 squared. So when I factor it, it's going to look like this, where it's going to be something plus something in parentheses and then squared. What is the first something going to be? X. What is the second something going to be? 3 over 2. And now I'm going to go ahead and simplify the 3 over 2 squared and make that into 9 over 4. Remember, to square a fraction, I square the top, and then I square the bottom. 3 squared is 9, and 2 squared is 4. Everyone okay so far? And now my last step is to get the y by itself. I'll start by combining my like terms here. So if I want to take negative 5 and add 9 over 4 to it, what do I need to do? Make a common denominator. Very good. In this case, what would that common denominator be? 4. So I'm going to take 5 over 1 and multiply it by 4 over 4. That's going to give me negative 20 over 4. And when I add, and then I add 9 over 4 to it, gives me negative 11 over 4. Now again, I'm trying to get the y by itself. So I'm going to add that 11 over 4 to both sides. So far, so good. What am I going to need to do to get rid of that denominator of 2, though? Someone say, wait. I just heard that. Might have been in the hallway. What am I going to need to get rid of that denominator of 2? What do I need to do that? Multiply by 2. So I'll multiply this side by 2, and I need to multiply that side by 2. So on the right-hand side, that 2 distributes. Can I multiply that 2 inside of the parentheses there? Important question. No. And the reason I can't is because if I did, I'd be violating the order of operations, because I have this exponent outside the parenthesis, right? I have to take care of that exponent before I'd be allowed to multiply that 2 inside of the parenthesis. So I'm going to just stick the 2 right out on front, like that. I would do that every single time on this kind of problem. And then what do I get when I multiply 2 to 11 over 4? You should be able to do this in your head. Get 11 over 2. All right? 11 over 4 times 2 over 1. You reduce as you multiply, and you're left with 11 over 2. Zach? Sure. So far okay? All right. We'll do one more here. Is that far enough? Okay. Madison, you good? Okay. So our next one here, y equals 2x squared plus 3x plus 5. What's the first thing I want to do? Make the a coefficient 1. To do that, I will divide both sides by 2. And I remember that division is distributive. So on the right-hand side, I'd get x squared plus 3 over 2x plus 5 over 2. What should I do next? Or what do I need to do next? I have to get those x's by themselves, right? So I have to subtract that 5 over 2, the c, from both sides. Okay. Now what do I do? Add b over 2 squared to both sides. So I'm going to write this in kind of a funny way. My b is 3 over 2. So I'm going to write this as 3 over 2 squared. I'm sorry, I just want to check something real quick here before we get going too far. So what does 3 over 2 over 2 really mean? It's really the same thing as 3 over 2 divided by 2, right? Everybody agree with that? That a fraction is basically the same thing as a division problem? And I remember to divide fractions is the same thing as multiplying by the reciprocal. So when we multiply fractions, we just multiply straight across. So I get really 3/4 there. So again, I didn't want to do too much there too soon, but I am going to, on this next step, write that instead of 3 over 2 over 2, I'm going to write that as 3/4. I didn't want to do too much fraction stuff too quickly there. So I wrote it down as 3 over 2 over 2 to show you kind of how you would have to go about simplifying that. Is everybody okay with that? All right. So the next thing I should do is I factor this piece, correct? When I factor that, I get something that looks like this. What is the first piece? X. And what is the second piece? 3/4. Everybody happy with that? And what's left to do then is to get the y by itself. So I'm going to go ahead and rewrite 3/4 squared as 9 over 16. Remember, to square a fraction, we square the top and then we square the bottom. So 3 squared is 9 and 4 squared is 16. Now what I'll do is I'm going to combine the negative 5 over 2 and the positive 9 over 16. To do that, I need to have a common denominator. That common denominator would be 16. To turn 5 over 2 and to have it, or to make 5 over 2 have a denominator of 16, what do I need to do? Yeah, multiply by 8 over 8. So when I do that, I get negative 40 over 16, and negative 40 plus 9 is negative 31, and then it's still all over 16. So we'll then add 31 over 16 to both sides. And then multiply both sides by 2. Oops-a-daisy. Forgot that. So the 2 times 2 and divides by 2 cancel out. When I distribute the 2, I know that 2 can't distribute inside of the parenthesis. So I'm just going to stick that out front. And I multiply the 2 to the 31 over 16, I get 31 over 8. Again, remember that 2 over 1 times 31 over 16. We can reduce as we multiply and just make that 31 over 8. Caden? So the last step is to get the y by itself. So I had to get rid of the dividing by 2 attached to the y, is why I did that. Justin? Of course. So this is as far as I wanted to go today. I have an assignment for you guys on Power School where I give you 2 of these completing the square problems to do as homework. Just 2. Because, again, the process is a little bit lengthy. I want to make sure that I see the steps when I look at your homework. So I want to see the work similar to what we've done in the notes when I'm looking at your homework. On that assignment, I listed the answers because I think that would, for this homework that's rather lengthy, at least the steps are rather lengthy, I think it's helpful to know when you are finished whether you did that correctly or not, so you can go back and double check it, especially with a small assignment where I'm just asking you to do 2 of these. I think that'll be rather helpful, but I do expect to see like the written out work similar to what we've done in the notes to accompany those 2 problems. Everybody okay with that plan? So short assignment, but that's okay because this process is a little lengthy. I don't want to give, like 2 hours of completing the square homework, which is like kind of unbearable, right?